Hello, students. Sorry I'm late. Mr. Jackson is out sick today, so even though I haven't taught for a while, I'm going to be your substitute teacher for today's class. Now, I know that I won't be able to match Mr. Jackson's teaching ability and his enthusiasm, yet I think that you will all enjoy today's class because differential equations is my favorite subject in the whole wide world. Now, I trust that you all have the ability and competency to do this warm-up problem. So you can ask me any questions while I take a quick smoke. Yes, handsome young man in the back. You'd like to hear about the time that I helped build the atomic bomb for the Manhattan Project? Well, that's an excellent question. But if I tell you about that, then I'd have to tell you about the time that this and, well, I'll start at the very beginning then. In 1909, Ernest Rutherford released his gold foil experiment and the Rutherford model of the atom shortly thereafter. Because of this, it became apparent that nuclear physics and Newtonian physics existed under completely different principles, and they became separated. As a result, a golden age of physics had begun, with papers from the most prominent scientists being released every week, and rapid developments being made all the time. I hopped on as a young physicist trying to get in on some of the action. So shortly after getting my undergraduate degree at Harvard, I moved to Europe to study at Cambridge and Göttingen under some of the brightest minds in the world. And people like Max Born and J.J. Thomson were there to help inspire me. And after studying in Europe, I moved back to the United States to accept a joint professorship between UC Berkeley and your university, Caltech. With my students and colleagues, I tackled important problems such as molecular band spectra, cosmic rays, and I even dipped my foot a bit in antimatter. Yet, it was very difficult to appreciate the scientific developments being made at the time, in light of the Great Depression. I could see hundreds of thousands of people unemployed and homeless just a few miles from my university, and I knew something had to be done. So, at the time, I became more than a physicist. I became a humanitarian as well. I donated to left-wing causes that advocated for workers' rights. I attended meetings for groups against fascism, and I even attended a few meetings of the Communist Party of the United States. Yet this would come back to haunt me. But with all the time I was spending in humanitarianism, it was difficult to recognize that my colleagues were being distant. I thought maybe they're just hard at work in their own problems, made to focus. Yet it was going on for far too long for this to be the case. So I knew something was up. After months of being kept in the dark, the Department of Defense offered me a job as the coordinator of rapid rupture to work on fast neutron theory. I threw myself at this work with full vigor, even though I didn't know what the end result was going to be, or what I was even working towards. Yet it all changed when the Manhattan Project was officially established, and I was appointed as the scientific director. As a scientific director, I was responsible for presiding over the heads of the 4 divisions: chemistry and metallurgy, theoretical physics, experimental physics, and ordnance. And I was responsible for creation of nuclear weaponry for the United States to use in World War II. So, week by week, we brought this hypothetical bomb closer to reality. Yet, while the Soviets were being killed on the battlefield, we retreated to our villas for cocktails and chatter. It wasn't fair, all of us knew it, yet there wasn't much that we could do. My good friend Hakan Chevalier approached me, and he asked if I could offer any nuclear secrets to the Soviet Union to help with their bomb-building program, to perhaps help with their conflict against the Nazis. And I told him, no, I can't give you this, but I didn't report the incident to General Leslie Groves until months after it had happened. And because of that, I had to testify about this incident multiple times over the next few months to security boards. But I understood the cause for concern. There was a massive fear that our nuclear secrets would be stolen. If Germany gained access to our nuclear information that could help with their nuclear program, then they could perhaps make nuclear weapons before we could, which would mean losing the war outright, or even worse, the destruction of hundreds of major Allied cities around the world. And that was unacceptable. Yet, while the German threat was considered, the Soviet threat was also incredibly dangerous. While most American citizens at the time didn't want to criticize their wartime ally, the USSR, the administration was correct in considering a post-war world where the US and USSR would be rivals for power after the Nazis were defeated. So if we wanted to maintain any nuclear weapons any monopoly on nuclear weapons that we would get during the war, then we had to stop any infiltration, German or Soviet. And after all the worry and the years of hard work, We finally did it. Over the New Mexico desert, at the Trinity test site, in 1945 to July 16th, we detonated the first atomic bomb in human history. And it worked. Make no mistake, this wasn't just a normal bomb, because neutrons were breaking through electromagnetic barriers of atoms, splitting the atoms into even more and more neutrons, breaking into more and more barriers until all the critical mass had been exhausted. In fact, this was the first practical application of Einstein's equation E equals mc squared, where energy is equal to mass times the speed of light squared. We were creating massive quantities of energy from the fission of atoms, and while that was an exciting thought, it was sobering to remember what the energy was being used for after the first two bombs were dropped on Japan. The destruction of hundreds of thousands of lives. With that, the war was over. I accepted the position as the director of the Institute of Advanced Study in Princeton, and as the chairman of the General Advisory Committee of the Atomic Energy Commission. And I knew that a nuclear arms race between the US and USSR would be developing rapidly, and I tried to do all that I could to stop it. So I lobbied aggressively for the United Nations to control all fissionable materials necessary to create nuclear energy, so that we wouldn't have a nuclear arms race, and any nuclear energy would be used for good rather than for evil. Yet, higher-ups in the administration manipulated the proposal so that the US would maintain its monopoly, but the USSR would have to give up any dreams of getting nuclear energy on its own. The USSR rejected this proposal, of course. Yet, perhaps even worse than political hardlining was the degradation of the scientific community in the United States. My good friend Niels Bohr once said that the purpose of science was a gradual removal of prejudice. Prejudice that the world was flat, prejudice that disease came from God to kill those who weren't pious. But it seemed to me that the only way prejudice would be removed is if it was in the way of killing hundreds of thousands of innocent civilians. And in fact, it never was. But it turns out that the scientific community, rather than being a beacon of enlightenment, was just becoming a cog in the ever-increasing military-industrial complex of the United States. But perhaps the most important moment in my post-war career was my opposition to the hydrogen fusion bomb. Fusion, unlike fission, creates far more energy with hydrogen isotopes combining into helium. And this meant that potentially much more destructive bombs could be made. And I opposed the creation of these bombs, instead advocating for reliance on fission bombs. If you destroy, say, a munitions factory with a fission bomb, that's all that you needed to do. All a fusion bomb would do is kill hundreds of thousands of civilians in the blast radius, which serves no tactical purpose other than genocide. And even though I opposed the creation of these bombs, President Truman decided to go ahead for research anyway. And I couldn't help but feel dejected that even though I had opposed this, my advice just wasn't being heeded. But if I had any chance at influencing political decisions, it all ended when I chose to testify in my defense in a security hearing to take away my clearance. And even my communist affiliations, my contact with Hakan Chevalier, my opposition to the fusion bomb brought on by the military-industrial complex were all brought up to destroy my name. My good friend Albert Einstein at the Institute of Advanced Study told me that I should resign my position rather than fight these charges in a kangaroo court. And I thought he was an idiot at the time, but it turns out that he was right. Because my lawyer didn't have any security clearance, so all the documents that were being brought up against me, he didn't have any response to, and we had virtually no defense. And just like that, I became perhaps the most prominent victim of McCarthyism, just because I opposed a potentially genocidal nuclear agenda. Just like that, the project that I had nurtured from its infancy into its adulthood had become the catalyst for a political witch hunt that would make me and hundreds of other scientists that opposed nuclear genocide lose their jobs in light of a nuclear arms race between the US and USSR. But I'm not going to stand here and feel sorry for myself. I understand the risks nuclear weapons pose, but it's not okay to say that the Manhattan Project was just all bad because it started the nuclear arms race and justified political witch hunts. Because we need to recognize that there's good as well as the bad. It's the reason that we have nuclear energy today, and it's the reason that the scientific community is much closer to the government than it ever has been before. So for better or for worse, the Manhattan Project changed the world, and I'm proud to say that I was a part of that change. Alright, where were we? Yes, differential equations. Anyone answer the question? Whoop, there's the bell. Okay, well, have a nice day, everyone, and don't tell your teacher that I went on this rant.